Hey everybody, thanks for jumping in. My goal of this video is to walk you through some of the results that you can get from running a gravity casting simulation using Altair Inspire Cast. Now with Inspire Cast, you can run many different casting processes like high and low pressure die casting, investment casting, gravity and tilt pour casting. For this example, we're just going to use the gravity casting process. Now you can see I have my component here. And before I ran the analysis, I had to define a few of the parts. First thing is my gate, and then I did have to create a mold component as well, which you can see here. So we can just now jump right into looking at the results. So we'll start on the filling side. And when you're looking at filling results, you're typically looking for potential defects that could arise during the process of the molten material filling your mold. So depending on your results, you can look at adjusting gate placement or fill time or temperature. So let's look at solid fraction. Now essentially this shows the areas that might be prone to not fill completely. If your model is solid red, that's a good thing. If you see some multicolored areas, then you can adjust the pressure, the velocity, or the filling. Next, let's look at cold shuts. Now this would be when you have two fronts of the material and they're interacting, so there's potential for them not to fuse together properly. You can look at the temperature differences in the mold fronts to see if they need to adjust in the filling process. This can weaken the structural integrity of the casting, making it more susceptible to defects, fractures, and premature failures. So now we can look at mold erosion. And this shows you where the velocity reaches that threshold where mold erosion can occur. With erosion, you'll start to see some roughness in the molds. It can lead to dimensional inaccuracies or surface defects or even some structural weaknesses in those final castings. Okay, so now let's talk about some of the solidification results. And with solidification, you're typically worried about the cooling process and how things like porosity and shrinkage can occur. Now with porosity, this refers to the small voids or those pockets of air that can be found in a finished part. With Inspire Cast, this is pretty straightforward. It shows you the areas that are voids versus solids based on your specified percentage value. Next, let's look at the NEMA criterion. And essentially, this is just a safety check for how well your materials are fused. So it helps understand the potential for shrinkage and microporosities. Now, when the NEMA value falls below a certain level, then micro shrinkage begins. The lower the value, the higher the probability of micro shrinkage porosity. So lastly, let's look at pipe shrinkage. It's very similar to the shrinkage porosity, but it typically occurs when you have a surface that's open to the atmosphere, and the air will compensate when the shrinkage occurs. So hopefully this has shown you how much valuable information you can get from running a simulation inside of Inspire Cast. If you have any further questions, please contact us at trueinsight.io.